In this short video and in the next few videos, we're going to be talking about utility. Utility is a convenient measure that we use in economics to determine the relative appeal of different options a consumer could make. It might be different baskets of goods or something like that. A key thing is that utility is ordinal. It doesn't tell us something about the level of happiness, but we assume that baskets that provide higher utility are strictly preferred to baskets that provide lower utility. And therefore, it forms a convenient way to analyze which choices are preferable for a given consumer. Okay, so we're going to start by illustrating utility, and we're going to use indifference curves to illustrate utility. Now, most of the time, we're going to make three assumptions. And this is both to make the graphical illustrations and the calculus-based solution methods easier, or sort of make it so that they work. Okay, so let me start by drawing an indifference curve graph. So what I'm going to do is I'm going to draw a graph with two goods, where the quantity of one of the goods is on the vertical axis and the quantity of the other good is on the horizontal axis. And I'm going to call these two goods F and B. And I'm going to be inspired by my trip to Scotland when I studied abroad as an undergraduate student. F is going to stand for fried Mars bars. You may not know what that is, but if you don't, you could look it up. And B is going to be for Bismol in Pepto-Bismol, a medicine you take to make your stomach feel better. Together, they go very well. So we're going to make three main assumptions. We're going to assume that demand is continuous, implying that a consumer can consume any amount of a good, including any sort of fractional amount. So you could have, for example, 14.8296 or 16, etc. You can have any amount of a good. Think of it as like something like soup, where you could pour any amount of soup. It's not like one or two soups. You could pour like, an extra drop or half an extra drop or something like that. That's the first assumption. The second assumption we're going to make is diminishing marginal utility, that sort of each additional unit of a good that you have makes you a little bit less happy, or a little less incremental increase in happiness than the last unit. So for example, you might think that if you're really hungry and you get some French fries, that first French fry is really going to make you a lot happier than you would be with no French fries. Okay? Right? Because you're really hungry, French fries taste good, etc. Your second French fry would add a little bit more utility, but not quite as much utility as that first French fry added. And once you get to 1,000 French fries, the assumption is that the incremental utility of that 1,000th French fry, that is the utility beyond the utility that you get from 999 French fries, is smaller. But we are always going to assume that more is better, that 1,000th French fry makes you happier, at least a little bit. So those are the three assumptions. And with those three assumptions, we're going to draw indifference curves that have a very particular look. Before I get to that look, let me first talk about what an indifference curve is. An indifference curve is a combination of points, or a curve connecting a combination of points that all yield the same level of utility for the individual, implying that the consumer is equally happy at any of those points on the indifference curve. So for example, let's say that 10 units of fried Mars bars and 500 units of Pepto-Bismol provide a utility of 5 utiles. And suppose that 5 fried Mars bars and 700 units of Pepto-Bismol also provide a utility of 5. Okay. And you might have another point out here which also provides a utility of 5. So that implies that this consumer would be indifferent between these baskets, where the first basket provides 10 units of fried Mars bars and 500 of Pepto-Bismol. You give him a basket of that, or he'd be equally happy if instead of giving him that basket, you gave him a basket with 5 fried Mars bars and 700 units of Pepto-Bismol, etc. Okay. Now, because we assume that demand is continuous, there's actually going to be an infinite number of points that provide exactly the same level of utility of 5. And I'm going to try, actually let me use a different color. I'm going to try to draw an indifference curve through those points. Okay, so all of these points on this red line, which are on the same indifference curve corresponding to 5 utiles, are equally preferred by this consumer. Okay, so the consumer doesn't care which point along this line that they are, they'd be equally happy. So now let me talk about the assumptions and the look that they make for this graph, or how they make these indifference curves look. Okay. So so we're usually going to actually assume that indifference curves are convex. They're sort of curved up and to the right. You can extend it further along these dimensions. It's not like the indifference curve is ending, but it goes out a long way, getting gradually closer on this end to a flat line, but never quite becoming flat, etc. The diminishing marginal utility. The idea that each unit of a certain good provides you a little bit less incremental utility than the last unit did. Okay, so let's look at this point here. At this point here, this person already has a lot of fried Mars bars, but doesn't have that much Pepto-Bismol. If the consumer has relatively few units of Pepto-Bismol, it's going to make their stomach feel better after they have all those fried Mars bars, then to get that person to give up some of those precious few units of Pepto-Bismol, you're going to have to give them a lot of the good that they already have a lot of to get them to give that up, right? So if you sort of, to move on here, you have to go, sort of a small change in the amount of Pepto-Bismol and a large change in fried Mars bars to leave them indifferent. If you start at this point, it's the opposite. They already have, or I can actually make it even more extreme, I could say this point here. They already have a lot of Pepto-Bismol, but don't have much fried Mars bars. Then the relatively scarce good is the fried Mars bars. And to get them to give up some additional fried Mars bars, and they already have so few, you're going to have to give them a lot of Pepto-Bismol, which they already have in an abundant supply. Okay, so that's the basic idea of why these indifference curves are convex shaped. Okay, we're also going to assume, if we sort of draw this indifference curve map, that indifference curves that are further up and to the right correspond to higher levels of utility. Right, so this first one might have a utility of 5. This one, which is sort of up and to the right, provides a utility of 10. So all the points on this higher indifference curve are preferred to all the points on this lower indifference curve. Okay, so let me illustrate why the more is better assumption implies this. So if we look at this point, let's call this point B and this point A. We see that point B relative to point A, point B is further up and to the right, implying more of both of the goods. So basket B has more of both of the goods than basket A does. And by the more is better assumption, therefore basket B must be preferred to basket A, by the sort of starting assumptions that we used. It also implies that basket B is preferred to basket, let's call this C. Okay? We can't get there directly from the more is better assumption, but the more is better assumption tells us that basket B is preferred to basket A, right? And we know that points A and C fall on the same indifference curve, so they must provide the same level of utility. So A provides equal utility to C. Okay, so by transitivity, B is preferred to A, which is equal to C. Hence, B is preferred to C. Okay. So that is point B is preferred to every point on this lower indifference curve. So now I want to talk about another thing we're going to plot. We're going to plot the budget constraint. The assumption here is that this consumer who we're representing on this graph has limited income. Now we're going to ignore things like savings and other things like that. We're just going to assume that this is a static model where the consumer is trying to maximize their utility this period. And so they're going to spend their entire income, we're going to assume, because more is better, and if they were to spend less than their entire income, then that would not be maximizing their happiness. They could get to an even higher level of happiness or a higher level of utility by spending the remaining income on one of the two goods that we're assuming exist in this market. So let me start by writing down. Okay. Now the assumption without sort of before we require the consumer to spend their entire income, the more general assumption is that their income has to be greater than or equal to their expenditure. They can't spend more than they make. Okay, so their income is going to be greater than or equal to the price of good F times the quantity times the quantity of good F plus the price of good B times the quantity of good B, right? And the price times the quantity for either one of these goods just equals the expenditure on that good. So we add up the expenditure across the different goods, we get the total amount spent. And that has to be less than or equal to their income. Now let's just say this holds with equality. So I'm going to erase this. I already explained why we think a person would want to spend their entire income. So let's say that this holds with equality. And now what we're going to do, so we can actually plot it on this graph, is we want the variable which is on the vertical axis of this graph, QF, to be the dependent variable. So we're going to rearrange it. So let's subtract the price of B times the quantity of B from both sides. And that's going to give us that income minus price of B times the quantity of B is equal to PF times QF. And if we then divide both sides by the price of good F, we get that I over PF minus PB over PF times QB is equal to QF. So now we've isolated QF, the variable that we want to be the dependent variable, by itself on one side of this equation. And so this expression on the other side is what we plot. We're going to call that the budget line. It gives the set of bundles that are affordable. Right? So the budget line might look something like that. Okay. Now we're going to assume that any point on that budget line is affordable. Any point on this budget line is represents a basket where the consumer spends their entire income. They could also afford any basket that's further down and to the left of this budget line by spending less than their entire income. But for reasons that I said earlier, we're going to assume that they'd never want to do that. Okay. So now let's talk about how consumers' utility maximization is represented on this graph. So let me clear this canvas and I'll start over. So let me draw this here. I'm going to draw an indifference curve to start out. And let me draw a budget line. Okay. So let's look at these 2 points here. And these points right here, these black points right here, they are points that fall on both the indifference curve and the budget line. So it's a point where the person is spending their entire income. But these are not going to be points that are optimal. These are not going to be points that maximize the consumer's utility. And the idea here is that we can see that this point right here, I'm drawing between these two curves, it's up and to the right of the indifference curve that is depicted on this graph. Hence, it must be preferred to all points on that indifference curve that is illustrated there. Right? So this point A is preferred to all points on that indifference curve. Hence, any point on this indifference curve cannot be a point that was maximizing this consumer's utility. Just to reiterate, because point A is preferred to all points on the indifference curve, and because it's down and to the left than the budget line, it is a feasible consumption bundle. Okay. When will there not be an area between the indifference curve and the budget line? When will there not be a bundle that is preferred to any bundle on that indifference curve? Well, the answer is when we have a bundle where this is supposed to be continuous because we assume and differentiable. We're assuming that there's a point right here. Let me actually draw that again. We're going to assume that there's a point where they just touch. The indifference curve never crosses through the budget line. They just touch at that point. And for the indifference curve to not cross through, we're going to assume that the indifference curve and the budget line have the same slope at that point. Okay. And that is the point that is going to be the optimal bundle for that consumer. Okay, so let's say that that utility is equal to 7. Now there might be some other indifference curves which are further up and to the right. Of course, these would be preferred, but because they never touch or fall below the budget line, they are infeasible. The person would not be able to afford these points along these higher indifference curves.